WASA Distance Education and PLAR Science. So
Recording in progress.
this is our last class for this week, and as you notice, for this week only, this is week 5. That PLAR Math ran on Tuesday and Wednesday, so today is Thursday, May 16th, and we have our PLAR Science. It's also the long weekend, so on Monday we do not have PLAR Science. We don't have classes on that day. That's on the 20th. So our next class won't be until the 22nd. Okay, so that will be on Wednesday. So PLAR Math will still run on Tuesday, the 21st. So hopefully we'll have good weather for the long weekend. I don't think so, but it's still good to be hopeful. Okay, so we still have courses for term 3. So if you're interested in applying, it will be from June 24th to August 23rd. So 9 weeks. So it is the summer term. We call it term 3. Application deadline is on June 28th. You will see that the poster that we are circulating, it will have a QR code. So if you use your phone to scan it, it will take you to the sign up, or you can go to our electronic application form and you just have to go to that link. It's tinyurl.com WASA sign up. Courses available: English, Math, Science, History, and Co-op. So you will see that it has the columns. For English, you can apply for NBE 3C, ENG 3E and 4E, ENG 4C, 4U, and OLC 4O. For Math, we have MEL, which is the grade 11 workplace math. There's also grade 11 college math, MBF 3C, the grade 12 college, the MAP 4C, and the grade 12 college math technology, which is the MCT 4C. For the sciences, we have grade 10 applied, we have grade 11 workplace, we have grade 11 college biology, the SBI 3C. If you're needing the grade 12 college chemistry, SCH 4C, or the grade 12 university biology, which is the SBI 4U. Co-op is also available, DCO 3O. And for history, we have CHC 2P, which is the grade 10 applied history, and the NBV 3E, which is the workplace native studies. So lots of courses available for you to take during the summer term. So students who are perhaps applying to college or university and you're needing certain courses, look through those and see if there's something there that could be useful for you. Term 2B draws, that's still happening. We will have 2 student draws, one for students who earned a credit and one for students who submit work. So make sure you're submitting your work to your teacher so that we can enter you into the draw. Students working on more than one course will have their names entered for each subject that they submit work for. Okay, most of you are familiar with how to contact your teacher. Remember, that's all on the first page or cover page of your lessons. It will give you the office number, the fax number. Depending on which course you're taking, it will give you your teacher's email, Facebook, office hours, and so on. For submitting your key questions, you can have your DEC fax, scan email to student work at nnec.on.ca. Make sure you CC it to the teacher who's marking your work. You can use your notes app to scan it yourself. You can scan and email it. You can send a picture through Messenger. You can drop it off at our WASA office. There's also an outdoor mailbox on the side entrance if you want, or you can just knock on the door. Or you could also use your Google Docs to share your work. So here's an example. A student shared their work with me. I just crossed off their name, but I got an email saying John Doe, or whatever the student's name is, shared a document, and then it shows me the the document that's shared. In this case, it's the PLAR geography. Notice how it says, it gives me the person's email, has invited you to edit. So that one, the student gave me rights to edit. You can change that. You can change it to view instead of edit. If you put edit, that means I can change stuff on there. In this case, what I did was I put his name on the top of the page and the lesson and key question numbers. So lots of ways to do that. Extra support for students who want to watch the classes. So if you're unable to attend classes, you can still watch them through YouTube. There's a playlist section for both PLAR Math and PLAR Science, PLAR History, PLAR Geography, and PLAR English. You can watch the PLAR Science 2B 2024 playlist. That will have all the classes for this term. If you're working ahead of me, you can watch the classes under PLAR Science 1B 2023-24. Notice it has the 16 videos in there. So if you're already working on lesson 4 or 5, you can watch the classes there. If you don't have access to internet or Wi-Fi, you can also request a USB of classes. Remember, you need a USB port to insert your flash drive. You simply open the class or video. Each class is named. So for example, for PLAR Science, it will say PLAR Science. It will give you the lesson number and the key questions that's within that video. So if you're having problems with a certain key question, you should look at which key questions are in the class. We're looking at the teacher comments or marks to students. We have so far completed lesson 1, astronomy, lesson 2, biology, and in lesson 3 we have key questions 41 to 49 completed. So this afternoon we will begin with completing key question 50. And in your lesson book, in your lesson 3, you will see this. It's more detailed. It tells you the topics for each key question, and on the right hand side it gives you the total marks. As I mentioned, this is great for students who want to keep track of which key questions they're working on, or if there's a key question that you're having problems with, you can skip over it, but you can put a circle on it and contact me. Say, for example, you're having problems with elements. That's key question 46. So save that, then you go on to the next question, and then when you call me, or you can send me a message on Messenger, you can just let me know that, this is the key question that I'm having problems with. Okay, instead of stopping everything, you can just skip over it and then contact me. But it's a good way to keep track of the key questions you're working on. So this afternoon we will look at page 22. So we finished with page 18, which is the periodic table. Now on page 22, what are compounds and molecules? Page 25, what is a chemical formula? Page 28, how is a mixture different from a compound? Page 33, physical changes versus chemical changes. So let's do a quick review here. First of all, learning goals. What will you learn? You will understand how matter is classified into pure substances and mixtures. You will be able to explain the difference between a chemical reaction and a physical change, and I can explain what happens in a chemical reaction. So again, we will review the classification of matter chart. So make sure you know this. Okay, this will be in your culminating activity. So matter, everything that's around you, whether it's a solid matter, a liquid matter, or a gas matter, it can be classified as pure substances and mixtures. If it's a pure substance, it can then be subdivided into either elements or compounds. So for example, gold is an element and water is a compound. Okay, that's under pure substances. Mixtures, it can either be heterogeneous mixture or homogeneous mixtures or homogeneous mixtures. Notice the difference between hetero and homo. Hetero means different. That just tells you that in the mixture you can pick out the different parts or the different substances. So this is a salad bowl. You can pick out the different parts. You can see the tomatoes, the cucumbers, the lettuce, the onions, the radishes. So if you don't like something in that salad, you can literally pick those out. Homogeneous mixtures. So this one is juice. It's red. So let's say that is a strawberry juice. In this case, all you can see is that it's a liquid matter, and it's red. So, like I said, it might be strawberry juice, so it must have strawberry syrup in it, or crystals, but it's been dissolved. You can't pick out the parts. That means you can't see the sugar that's possibly in there. You can't pick out just the water that's in there. You know there's water in there because it's liquid. So that's why it's called a homogeneous mixture, because it looks like everything in it is the same. Okay, you can't pick out the different parts. And we also looked at, here's our other review. On page 17, regarding elements, we said elements is any sample of matter that is made up of only one kind of atom. We said that elements are represented by symbols. So for example, oxygen, the symbol for oxygen is O. For carbon, it's C. For hydrogen, it's H, and so on. And then those elements, lithium, helium, argon, and silicon, their symbols, first letter is capital, so L, and the second letter is lowercase I for lithium, helium, capital H, lowercase e, and so on. So the language of chemistry is the same all over the world. So it doesn't matter where you live, whether you live in China or England, anywhere. The symbols are the same. So the language of chemistry is the same. That way, we can avoid confusion. Just think of all the different languages that are spoken in different places, but the symbols remain the same in the language of chemistry. Okay, up next, this is what we're starting on, are compounds and molecules. So compounds, like elements, are pure substances. When we talked about water, water is a compound because it is made up of 2 parts hydrogen, 1 part oxygen. So each particle of a compound is made up of a collection of atoms. So the atoms doesn't just mix together, they are joined by chemical bonds. A compound has 2 or more atoms that are joined chemically. They are made from the elements on the periodic table. So as I said before, we said hydrogen, the symbol for hydrogen is capital H. When you see a number below it, so H2, that means 2 parts hydrogen, and then O for oxygen, that means 1 part of it is oxygen. So as there are approximately 118 elements in the periodic table, there is an unlimited number of ways these elements can be combined to form compounds. Just like I mentioned, when you look at 26 letters in the alphabet, you can mix and match those letters to form different words. So the properties of a compound are often very different from the properties of the elements that make up the compound. So what happens to the elements in the compound? Well, they lose their own properties. The compound takes on new properties. Compounds do not even have to be in the same state as the elements of which they are made. So for example, hydrogen and oxygen are both gases. But if you link them up, or if you chemically bond them to make water, they become a liquid. So you have 2 gases, now it's a liquid. A compound must have at least 1 metal element and 1 non-metal element. Most compounds are found in nature. However, some compounds are made by scientists. Okay, up next, so we just looked at the word compound. Notice that compounds are, or that word, this is bolded in your book. That means they're darker. So the next one is a molecule. Now, a molecule is the smallest part of a compound, okay, which means that it still has the properties of that compound. Take, for example, if you have a big piece of a chocolate bar, if you broke a piece of it, it will still taste like that chocolate bar. Okay, it's just a piece of it. So think of a piece of the chocolate bar as a molecule. A molecule has 2 or more atoms linked together. Some molecules have thousands of atoms, but not all molecules are compounds. So here's some examples. So molecules of elements. Here is helium. Notice this one, hydrogen. It's a molecule because there's 2 of them. And oxygen. You have 2 of them. Notice the number. For helium, there's only 1, so capital H. For hydrogen, you have H2 because there are 2. And oxygen, notice there's also 2. They're still molecules. Molecules of compound. This one is water because this one is H2O. So here's the O and here's the H. That means it's 2 parts. You have ammonia and you have carbon dioxide. So carbon dioxide is CO2. So the oxygen is there and C is the big black one there. So let's look at water a little bit more closely. So when you look at water, we know it's a liquid compound. I mentioned that already. If you have a glass of water, it will have billions and billions of water molecules. So each molecule, water molecule, is exactly alike, which means that each of those molecules will have all the properties of water. That tells us that the smallest part of a compound is just 1 molecule of that compound. So remember I said that hydrogen is an invisible gas element. Oxygen is also an invisible gas element. You take 2 parts hydrogen, 1 part oxygen. It becomes water, which is a clear liquid, and it's now a compound. So 1 molecule of water is made up of 2 hydrogen atoms bonded with 1 oxygen atom. So here is the molecular formula. Okay, is H2O. So remember, if you don't see a number, that means there's one element of that atom. Salt. So table salt is a compound. Table salt is made up of sodium and chlorine. So sodium is a dangerous solid element. Chlorine is a deadly gas element. You put them together, you get sodium chloride, which is a safe white solid compound. Okay, we use it to season our food. So sodium chloride is also known as salt. Next up is carbon dioxide. So if you look at carbon dioxide, it is a gas compound and is made of the elements carbon and oxygen. So carbon is a dark solid element. Oxygen is an invisible gas element. You put one part carbon, 2 parts oxygen, you get carbon dioxide, which is an invisible gas compound. Carbon compounds make up 18% of all the matter in living things, and carbon is also used by humans to survive because it provides most of the energy. Oxygen is the most common chemical element found on or in Earth. Okay, it's one of the main elements that make up air, which is necessary for the survival of all plants and animals. Oxygen is a gas without color, smell, or taste. It turns into a pale blue liquid at temperatures below minus 180 degrees Celsius. And then it becomes solid at about minus 218 degrees Celsius. Okay, let's now look at what is a chemical formula. So turn to page 25. So each element, we said, has its own chemical symbol. So each compound has its own chemical formula. Now what a formula does is it tells us 2 important things about a compound. Okay, it tells us what elements are in the compound. It also tells us how many atoms of each element are in a molecule of the compound. Okay, let's try the formula for table salt is NaCl. So we know that Na is the symbol for sodium, Cl is the symbol for chlorine. That means one molecule of NaCl has a total of 2 atoms. We know that because one of the atoms is sodium, which is Na, and the other atom is chlorine. Remember, if you don't see a number beside the formula, that means it will contain 1 atom of that element. So you can see that sometimes a symbol has a small number written next to it. That number tells us the number of atoms there are of that element. So Na plus Cl2, that means there's 2 parts chlorine to make table salt. So Na plus Cl2, so sodium metal plus chlorine gas gives us table salt. Okay, let's look at, we can look at water again. So this is the chemical formula for water, is H2O. We know that H is a symbol for hydrogen, O is a symbol for oxygen, but because you see the 2 to the right hand side of H tells us there's 2 atoms of hydrogen. So one molecule of H2O then has a total of 3 atoms. So 1, 2, 3. And a change in the formula means that a new substance was formed. So it's helpful to learn to recognize some chemical symbols. However, if you don't see one that, if you see one that you don't know, you can always look it up in the dictionary. You can also Google it, or you can look at a chemistry book if you have one. So this number that's below the letter is called a subscript. If you don't see a subscript, that just tells you there is one oxygen atom, or there's one atom of that element. Let's look at some more common molecules. Mercuric oxide is the name. Elements, mercury and oxygen make up mercuric oxide. Number of atoms in each element. So if you look at there's one atom of mercury, one atom of oxygen. Total number of atoms is 2. Okay, KCl, I forgot to put the formula for mercuric oxide, so that would be just HgO. Okay, KCl is potassium chloride. Elements are potassium, okay, and chlorine gives us one atom of potassium, one atom of chlorine, so total are 2 atoms total. So you can see for mercuric oxide, common, you might see it in as a battery, like a watch battery. And then for potassium chloride, okay, you might see it in pellets for water softener. Okay, that's what it may be used for. Could be also used for food industry. Potassium chloride powder. Okay, others, sodium hydroxide formula is NaOH, which is commonly known as lye. So you see Na means you have sodium, O is oxygen, H is hydrogen. Again, you do not see a subscript, so you don't see numbers below it. That means there's one atom of each of those elements. So the total number, so 1 plus 1 plus 1 equals 3. So 1 of sodium, 1 of oxygen, 1 of hydrogen. And there are various household uses of sodium hydroxide. So if you think about it, you may also have been using this for cooking purposes, or washing and chemical peeling of vegetables and fruits. This substance can also be bought from various bulk drugs manufacturers. Okay, it's commonly known as lye. Here's another one. The formula is Fe2O3. Notice the subscript. So that's what I mean by when you see a subscript, there's a number. This is commonly known as rust. So iron oxide is rust. So you have iron and oxygen. Notice for iron, you have 2 parts. And for oxygen, you have 3 parts. So you would add 2 plus 3, that gives you 5. So you have 5 atoms in total in one molecule of iron oxide. Okay, and then the last one we have is sulfuric acid, or H2 SO4. Okay, another clue is when you look at the capital letters, so that's a capital H, capital S, capital O, that indicates that there are three types of elements. Because remember, when we write elements, they are capitalized. So you have hydrogen, sulfur, and oxygen. Then the subscript. So H2 means 2 atoms of hydrogen. You don't see a subscript for sulfur, but you already know that if you don't see a number there, that means there's one of that. And then there are 4 atoms of oxygen. So you would have to add 2 plus 1 plus 4, which gives you a total of 7 atoms in one molecule of sulfuric acid. So this one is used for 15% of its detergents, 30% used for ammonium phosphate and ammonium sulfate, so for fertilizers. Paint and pigments, 11% contains sulfuric acid. Other uses, explosives, pesticides, dyes. It's also used in batteries. Okay, so this is the last one. The last one is NaHCO3. So that's the formula. I'll just make it bigger here. So NaHCO3. Now notice you only see one subscript. But that tells us that Na means there's one atom of sodium. H gives us one atom of hydrogen. C gives us one atom of carbon. And we already know that the subscript 3 tells us there's 3 atoms of oxygen, okay, in sodium hydrogen carbonate, also known as baking soda. So just add those all together. You have 1 plus, oops, you have 1 plus 1 plus 1 plus 3. So simple adding. So you have 6 atoms in one molecule of baking soda. Okay, let's try key questions 50 and 51. Okay, we'll do key question 50 together. So the formula for starch is C6H10O5. Okay, I'm going to make that bigger here. C6H10 and O5. The first question says, how many kinds of atoms can be found in starch? Remember, the atoms are the capital letters, okay, because they signify what the atoms are. So C stands for carbon, H stands for hydrogen, O stands for oxygen. So how many kinds? There are 3 kinds, okay, of atoms found in starch. How many atoms of hydrogen? So focus on the element hydrogen are in one molecule of starch. So look at H, because that stands for hydrogen. The subscript tells us that there's 10. So we know there are 10 atoms of hydrogen. How many atoms of carbon? So look for the letter C, because C stands for carbon. And beside it, so the subscript tells us there's 6. So we have 6 atoms of carbon in one molecule of starch. Now it's asking you for what is the total number of atoms. So remember, there are 3 kinds of atoms. There's carbon, hydrogen, and oxygen. So now we're going to add 6, because there are 6 carbon plus 10 hydrogen plus 5 oxygen. So 6 plus 10 is 16, plus 5 gives you 21 in total. Okay, next one is the chart. So key question 51. You will complete the columns with the missing information. Notice that the first one, this one is done for you. I wrote a note there. If you don't see a number beside the element, it means it has one of that element. And I gave an example there. For example, CH4, which is the formula for methane. C is carbon, which means it has one atom of that element, even though you don't see the number 1. H stands for hydrogen, and you notice the number 4 is the subscript, so the number that's beside it to the right. So altogether, there are 5 atoms in one molecule of methane, because you're adding 1 plus 4, which gives you 5. Okay, your example for this chart is MgO. That stands for magnesium oxide. Number of elements, well, we know that Mg stands for magnesium, and O stands for oxygen. So there are 2 elements, magnesium and oxygen. Number of atoms of each element. For magnesium, we only have 1. For oxygen, we only have 1. So 1 plus 1 gives you 2. Okay, next one is Epsom salts. That's the name of the formula. MgSO4. So number of elements, again, I said if you look at the number of capital letters, there are 3. So Mg stands for magnesium. S stands for sodium. Sulfur. Just erase that one. Okay, sulfur. Make sure I'm spelling that properly. And O is oxygen. Look at the numbers or number beside Mg. You don't see a number, so we know there's 1 magnesium. Sulfur, you don't see a number there, so we know there's 1. Oxygen, you see the number 4. So 4, you add that all together. 1 plus 1 plus 4 gives you a total of 6 atoms in one molecule of Epsom salts. Okay, try the next one, hydrogen peroxide. So again, H2O2. So H2O2. Iron oxide, if you're not sure how to do this one, we just did that. It's in your book. So Fe. So this one shows you that the subscript is right below the element. Table sugar. Okay, let's try this one. This one would look like this, C12H22O11. Number of elements, well, we see C, H, and O. So we know there are 3. They are carbon, hydrogen, and oxygen. Those are the 3 elements. The subscript beside carbon, there's 12, so 12 carbon. There are 22 atoms of hydrogen in table sugar, and there are 11 atoms of oxygen in there. So simply add 12 plus 22 plus 11. So that gives you a total of 45. And finally, this is also in your book, NaHCO3, sodium bicarbonate, also known as baking soda. So look at the number of elements, write out the names of the elements, number of atoms of each element, and then it will give you the total number of atoms in one molecule of baking soda. So that one you shouldn't get wrong, or the iron oxide, because that is in your book. Okay, so that was key questions 51 and 52. Okay, next up, let's look at how is a mixture different from a compound. So sometimes you get two or more substances that are mixed together, but they're not combined chemically, so they don't make a compound. What they do is they make a mixture. So the substances are physically combined. None of the substances in the mixture has been changed chemically, and you don't get a chemical reaction. You don't get any new substances forming. A good example is vegetable soup. It's an example of mixture. So is salt and sand that's mixed together. But when you look at them, you can still one part from the other. So if you look at the mixture of sand and salt, you can still say, oh, I can see the salt there, I can see the sand there, but you know they're mixed together. Same thing with jelly beans, if they're all different colors. Okay, that's a mixture. You can still tell the red ones from the green ones, from the brown ones, and so on. So how can we tell the difference between a compound and a mixture? When you have a mixture, that means you have two or more materials or substances that are mixed together, but they are not chemically combined. This means that they retain their original properties, and it also means that you can still separate them by physical means. Just like the salad. Okay, you can still pick out the different parts. So mixture, two or more substances mixed together without actually joining them so that they can be separated again. Okay, a compound is different because you have two or more elements are combined, but when they are combined together, they are combined together by bonds. That means they're chemically bonded. Baking soda, sugar, okay, salt like sodium chloride, these are all compounds. So a chemical compound is a pure substance made up of two or more elements. So the elements in a compound lose their properties, and then the new compound has its own chemical properties. An important feature of a compound is that the ratio between the parts of a mixture is a fixed amount. Just like when we say H2O, which is water, it's a compound. It's a fixed amount. You have to have 2 parts hydrogen, 1 part oxygen to make water. Energy is always taken in or given off when a compound is broken up or put together. And a compound can be separated only by a chemical reaction. So for example, electrolysis changes water, H2O, into hydrogen and oxygen. That's the only way you can reverse the compound of water, is using electrolysis. Okay, another example is salt. We said NaCl. We said sodium is an element, chlorine is an element. However, when you have sodium and chlorine bond, they make the compound sodium chloride, which we know as table salt. Now, compounds have different properties than the elements that make them up. Table salt has different properties than sodium, which is an explosive metal and a chlorine poisonous gas. In mixtures, you can have many kinds of matter. It can have elements only. So for example, you can put sulfur and iron fillings in the mixture. You can have compounds only. So if you put tomatoes, lettuce, onions, okay, those are all compounds that are going into the mixture, or elements and compounds. So you might put sulfur, iron fillings, water, and sand. Okay, more about compounds. So salt and pepper. You can see that salt mixed with pepper is an example of a mixture. The salt and pepper are just close together. Okay, they do not react together. Properties do not change. The salt is still salt. The pepper is still pepper. You have no new products forming. It makes no difference how much pepper or salt there is. No exact amounts are needed. That means there's no fixed ratio. Energy is not taken in or given off by the molecules of the salt or the pepper. Salt is a compound, pepper is a compound. So salt with pepper is a mixture made up of two compounds. Okay, so we're going to stop here. And just a reminder, we don't have classes, so the WASA office will be closed on Monday for Victoria Day. That's on Monday, May 20th. Again, PLAR Science will resume on Wednesday. So when we come back on Tuesday, okay, you will be doing PLAR math. And don't forget to look at the courses for the summer term. It starts June 24th to August 23. The application deadline is June 28th for that, to apply for it. So make sure you talk to one of our counselors. You can also contact your local DEC. You can talk to Candace if you have a PLAR assessment, or if you have a new student in PLAR, or Michelle, and they'll be more than happy to help you. Okay, that's it for this afternoon, and I will talk to you again on Wednesday. Miigwech.